All right, we're going to add a new class called AVL tree. In this class, we're going to have a private class called AVL node. And in this class, we need a field for a value, so private integer value, and two fields for the left and right children. So private AVL node, left child, and right child. Now I'm also going to add a constructor for initializing a node object. So public AVL node, we give it a value, and here we set the value field. Pretty easy so far. Now, I'm also going to override the toString method because we're going to use this node object in the debugger. So public string toString. Here we return value equals plus this.value. And we should also apply the override annotation. So we're done with our AVL node class. Now, back to our AVL tree. Every tree needs a reference to its root node, so we add a private field of type AVL node and call it root. And now we're ready to implement the insert method. So public void insert, we give it a value. Here we need two methods, a public method to kick off the recursion and a private recursive method. So here's our public method. Let's also add a private method, private void insert. We give it a root node, so AVL node root and a value. Now, in our public method, we're going to call the private method and give it the root of the tree as well as this value. Now, in our private method, we have a few different scenarios. One scenario is where our tree is empty. So if root is null, we're going to set it to a new AVL node with this value. However, with this code, we're not going to initialize the root field in our tree. We're only initializing this root argument over here. So here we should return an AVL node and set the root in our public method. Let me show you. So here we return an AVL node, and that means we should change the return type to AVL node. And then here in our public method, we set root to the object that is returned from the insert method. So here we're directly setting the root field. Okay? Now, if our tree is not empty, we should either go to the left or right child. And that depends on this value. So if the value that you want to insert is less than the value of the root node, we should go to the left side. So this is where we recursively call this method, insert, and give it root, the left child, as well as this value. Otherwise, we're going to call the insert method and give it root, the right child, with this value. Now let's imagine we have a tree with only one node. So we have 10 at the root. Now we want to insert 5. So when we call the insert method, this condition is going to be true. We're going to go to the left child. This is where recursion happens. At this moment, we're going to come back to this method. Here, root is going to be null because the left child of the root node is null, right? So our insert method is going to return a new node. Now we'll come back to the previous step where root was referencing this root node over here. So here we should get the object that is returned from the insert method and set root, that left child, to that object. Similarly, if we try to insert this value on the right side, we should get the return value, the return object, and set root, that right child, to that object. Okay? And finally, we should return the root object. This is how we implement the insert method recursively. Now compare this implementation with this other implementation that we have in the tree class. As you can see, our new implementation, our recursive implementation, is shorter and easier to understand. Now let's test our new method. So back to the main class. I'm going to create a new tree, a new AVL tree. Here we want to insert 3 values. Tree.insert, let's say 10, 20, and 30. Now I'm going to run this program using debugger so you understand exactly what is happening under the hood. So let's put a breakpoint over here and run the program using debugger. There we are. Now we need to step into this method. If you look at this toolbar, you can see the shortcut for stepping into a method is F7. So F7, Here we are. Now let's step into our private method. Once again, F7. So here root is null. Let's step over this line with F8. Our private method is going to return a new AVL node. Let's press F8 one more time. Now we're back in our public method. Our insert method returned a new object, and we're using that to set the root field. All right. Now let's inspect the current object. So in this object, we have a root node with the value 10. Both the left and right children are null. So let's press F8. Now back to the main class, we're going to insert 20. So once again, let's step into this method with F7. We kick off the recursion with our public method. Let's press F7 and step into this method. So currently we have a root node with the value 10. So this condition is no longer true. Let's press F8. Here we are. The value that we want to insert is greater than the value of the root node. So the else clause is going to get executed. Here we're going to use recursion to insert this value. So let's press F7 and step into our private method one more time. All right, here we're looking at the right child of the root of our tree. As you saw earlier, the root of our tree doesn't have any children. So now this root is null. So our private method is going to return a new AVL node. All right, we get this, and then we set root.writeChild to this new object. So let's execute this line. Beautiful. Now finally, we're going to return the root node, which is the node with value 10, because once we step out of this method, we're going to get back to our public method, and here we're going to set the root field to this object. Let's press F8 one more time. Now, in this tree, we have a root node with the value 10, and this root node has a right child with the value 20. Okay? Let's try it one more time. So we press F8, back to our main class. We want to step into this method one more time. So we press F7. Here we are in our public method. Let's step into this one more time. Now this is the beginning of our recursion. First, we start with the root node. That is the node with the value 10. So let's continue execution. The value that we want to insert is greater than the value of the root node. So we're going to recursively call our private method. Now we come back here. We are looking at the right child of the root of our tree. That is the node with the value 20. So let's continue execution. Once again, the value that we want to insert is greater than the value of this node. So we're going to go to the right side of this node. So here we press F7 to step into this method. Now, the right child of this node is null. So here we're going to return a new object, and we're going to set root.writeChild to this object. Now, in this context, root is the second node in our tree. That is the node with the value 20. So we're adding the 30 as the right child of 20, okay? So let's execute this line and return root. Now we're back to the previous step of recursion. At this point, root is referencing the node with the value 10. That is the root of our tree. So we're going back recursively, okay? Now we return this root node to our public method and use it to set the root field, okay? Now finally, if you look at this tree, you can see the root node has the value 10, its right child has the value 20, and its right child has the value 30.